All right, welcome to day 2. Your homework for tonight is video 3-2. It will work more with the definition of the derivative. We'll answer any questions you've had on the last couple videos tomorrow in class. So this is where we're going to start. So we've got a graph here. It is a position and time graph. It's always going to be important to look at our axes because sometimes we'll be given velocity and time graphs or derivative graphs. So always look at your axes and see what you're working with first. So they're saying that this represents an object that's moving along a horizontal line. So right would be considered moving in the positive direction and left would be considered moving in the negative direction. So you don't have to copy the graph down or anything, but what I'd like you to do, we're going to pause for about a minute or two, and I'd like you in your groups from this graph decide what intervals of time is the object moving to the right, what intervals of time is the object moving to the left, and what intervals of time is the object standing still. And again, we're defining the right as the positive direction and left as the negative direction. So going to the right. So we should be moving to the right when our object is getting further away, or in other words, has a positive slope. So we should be going from 0 to 1, and then again from 4 to 6. We should be moving to the left when the object is returning back towards the initial position, or in other words, has a negative slope. So that's on the interval from 2 to 3. And you could have written 1 second, 0 seconds to 1 second, 4 seconds to 6 seconds, 2 seconds to 3 seconds. That's fine too. And where is it standing still? Well, that's over a period of time where the position does not change. So that's on the interval from 1 second to 2 seconds, and again from 3 seconds to 4 seconds. Well, part B, we want to draw the graph of the velocity function. This is essentially what you did with Tango and Rumba last year. If you had a position graph and you wanted to go to a velocity graph, you used slope. So the slope of the position told you the velocity. Our first section here, we go up 3 over 1, so that is a slope of 3. Horizontal line has a slope of 0. That one we went down 2, right 1, so that's negative 2. That's 0, and this section has a slope of 1. So when you're graphing the velocity graph, you're really just graphing the slopes of the position graph. So this is our time now, and this is our velocity. We want to make sure we go into the negative sum, because we do have a negative 2 there. And we have 6 total seconds. So the first section had a slope of 3, and that lasted from 0 seconds to 1 second. So we'd have something that looks like that. And then we have a slope of 0 for the next 1 second. So we'd have our velocity graph look something like that. Then we're at negative 2 for a second, so we're down here. Then we're at 0 for a second, and then we're at 1 for 2 seconds. So this velocity graph corresponds with the position graph that we were given. So we talked about how the slopes in the velocity graph, or slopes in the position graph, gave us the coordinates in the velocity graph. So in other words, the slope in the position, and position you usually use S for, so the slope in the position graph, S of t, equals the y value in v of t. So going in reverse, the y value in v of t would tell you the slope. Like here, the y value is 1, so we should have a slope of 1 in the original graph. So next one. So we have a ball is thrown into the air with a velocity of 40 feet per second. After t seconds, its height is given by the equation. We want to find the velocity when t equals 2. Well, the velocity we just said is the slope of our position graph. Well, for a slope, we need 2 points. And they want at just t equals 2. So our technique to find an instantaneous velocity is to find the limit of the average velocities and see what happens when they approach 2. So one point that we want to work with is 2 comma whatever we get back. Well, if we sub in 2 up here, that would give us 80 minus 64, in other words, 16. So we get 216 is 1 point that is on the graph. And then what we want to see is, well, what's another point? What happens when another point gets really close to that? Well, we want to be able to keep changing that, so we want to write the general point. For any value of t, the y value would just be 40t minus 16t squared. And what we're going to do is we're going to calculate our slope and do the limit. Now, we actually did this process in our limits unit when we did tables. The first day we did it, we set up a slope, we put that in our graphs page, did a control T, and picked values that got close to the one we wanted. Well, we don't need to do that anymore because we have algebraic techniques for doing limits. So we want t to get close to 2. So we're going to do the limit as t approaches 2. And we're trying to find an instantaneous velocity. Well, the instantaneous velocity is just the limit of the average velocities, and those are just slopes. So we're going to do a change in y over a change in x. So we'll have 40t minus 16t squared minus the other y value of 16 over t minus 2. So our algebraic technique, when we see something like this, we would want to think factoring. If you put 2 in for t, we get 0 in the denominator. We know we have to do some other stuff. So we'll have limit as t approaches 2. It looks like 8 will go into everything. And let's actually take out a negative 8. When we take out the negative 8, let's rewrite it in standard form. So negative 8 taken out of that would give us 2t squared. Negative 8 taken out of this would give us a minus 5t. And then negative 8 taken out of the 16 would give us a plus 2. And we're all over t minus 2. Well, our goal is to get a t minus 2 to divide out, because then that would give us something that we can do with direct substitution. So let's see, if we let one of them be t minus 2, let's figure out what the other one would be, and we'll see if it checks out. So if you have t minus 2, we would want a 2t squared when we multiply out. So this spot would have to be a 2t. We want the last terms to multiply to positive 2. So we would need this as negative 1. And if you check your insides and your outsides, we would get negative 1t and negative 4t, which together would give us the negative 5t, so that checks out. So we've got our limit. We can divide out the t minus 2. That would give us limit as t approaches 2. We'd have negative 8 times 2t minus 1. And now this is something we can do with direct substitution. When we do our direct substitution, we no longer write the limit. This would be negative 8 times 3, or in other words, we would get negative 24. Now this was the instantaneous velocity we are finding. Our units were feet and seconds, so this is negative 24 feet per second. Now, why did we get a negative velocity? Velocity is a vector, meaning it has magnitude and direction. Our velocity is 24. The minus means we are heading in the downward direction at that time. So at 2 seconds, the object must be on its way back down with a velocity of 24 feet per second. All right, next one, we want to sketch a graph that has all of these qualities. So sketch yourself an XY axis. So we are given 1 point on our function of f, because we're trying to draw the graph of f. The 1 point they're given is here. Well, that's our x, that's our y, so we're given the point 0, 0. So we know 0, 0 is going to be a point in our graph. Well, the rest of these are points in our derivative graph. Well, the derivative is your slope. So this is saying in f's graph, at x equals 0, we should have a slope of 3. At x equals 1, we should have a slope of 0. And at x equals 2, we should have a slope of negative 1. Because the y value in your derivative graph equals the slope in the f graph. So all we're going to do is we're going to kind of sketch in little segments that have that slope. So at x equals 0, we want a slope of 3. So you've got to kind of use your scale and envision what a slope of 3 looks like. We want to draw a little segment right here so that it's got the slope of going up 3 and over 1. So an up 3 over 1 would look something kind of like that. Okay? Because if we extended that, that would go up to the point 1, 3. And we'll just leave that there for a second. Next, at x equals 1, we have to have a slope of 0. Well, it doesn't tell us where that point's going to go. But we know it has to be above the x-axis because left of that we were increasing. So we've just got to pick a spot and have a horizontal line there because that would be a slope of 0. And then at x equals 2, we need a slope of negative 1. Well, if you've got a slope of 0 at x equals 1, we're not going up anymore, so we would want to make sure this is somewhere below. Now, our slope of negative 2 means we should be going down 2 and over 1. So you kind of eyeball it. So it's essentially like we're trying to draw a line that goes to there. So you just draw a little segment that has that slope. Okay, it should basically be negative and not quite as steep as the 3 one. And then just draw in your curve. Okay, so that's roughly what we would have. So the main idea of this question is for you to get down the understanding that a y value in the derivative gives us the slope in the original. That is a key concept that will come up the whole year. A y value in the derivative gives you the slope in the original. All right, so we're going to do a few examples now. And we're going to show you both of the definition of derivative methods that we have. So the first way we're going to do it, we're going to find this function, and we're going to find f prime of a. Now, normally, we would have x, but this question had t. So what we saw in the video, we saw a limit as x approaches a of f of x minus f of a over x minus a. But the difference here is we have t's, so all those x's will just become t's. So it's the same process, we just have a t instead of an x. So we'll start out with limit as t approaches a. F of t. That means everywhere there's a t, replace it with a t. Or you can think of it as f of t is just our original function. So we'll start out and just write our original function. Minus f of a. The meaning of f of a is everywhere there's a t, replace it with an a. So we'll have 2a plus 1 over a plus 3. So that's just the numerator, f of t minus f of a. That'll be all over t minus a. So that's our initial setup. Once we get that set up, we need to think from last unit. Oh, if we have a limit where there's fractions being subtracted, we know our technique is to get common denominators. So this one is going to have to get multiplied top and bottom by a plus 3. And this one top and bottom by t plus 3. So this will become limit as t approaches a. So we're going to FOIL out the top. That's going to give you 2at plus 6t plus a plus 3 minus, well, we got to start a parenthesis because we're going to be subtracting a whole bunch of stuff. We'll FOIL out the 2a plus 1 and the t plus 3. That'll give us 2at plus 6a plus t plus 3. Okay, that's just from FOILing out. This will be over our common denominator. So our common denominator is t plus 3, a plus 3. And that was all over t minus a. So we're going to distribute our negative. That'll be limit as t approaches a. We'll have 2at plus 6t plus a plus 3. We'll now have minus 2at minus 6a minus t minus 3. And then everything else doesn't change. We'll give you a minute to get caught up to there. All right, so we've got some things that are going to add to 0. 2at minus 2at. Those will add to 0. We've got plus 3 and minus 3. Those will add to 0. And if we combine our like terms, we're going to have 6t minus t is 5t. A minus 6a is minus 5a. And we're over t plus 3 times a plus 3. Now the t minus a, we're going to write horizontally now. So let's do divided by t minus a all over 1. I can't stress enough, write the division step. Do not switch to multiplication in your head. I would say 60% of people make a mistake. Don't make that mistake. Write the division and then do the keep change flip. So we have limit as t approaches a. We got 5t minus 5a over t plus 3, a plus 3 times 1 over t minus a. Well, we want the t minus a to wipe out. Notice in the numerator, we can pull out a 5. The t minus a's will divide out. We're left with limit as t approaches a. This is 5 over t plus 3 times a plus 3. And now we're ready to do direct substitution. If this had been limit as like t approaches 7, we would replace all the t's with 7s. Well, that's not what we have, though. We have t approaches a. So we're going to replace all the t's with a's. So this would become 5 over a plus 3 times a plus 3. That would be a fine answer, or you could write it as 5 over a plus 3 squared. This would be what f prime of a is equal to. So our derivative at some specific value of a. So essentially what that means is if we wanted to find the slope of the tangent line at t equals 7, we could plug in 7 for a there, and that would represent the slope of the curve at that spot. Okay, this is a formula that allows us to find the slope at any specific spot. All right, we're going to do the same problem, but we're going to do it the h way now. Our definition of the derivative, which is what this limit is called, doing it the h way, is limit as h approaches 0, f of a plus h minus f of a all over h. And that should be really familiar. We did that in Unit 1, and that was the whole reason of doing it in Unit 1, to get you used to the mechanics. So we'll have limit as h approaches 0. F of a plus h means everywhere there is a t, we will replace it with a plus h. So we'll have 2 times a plus h plus 1 over a plus h plus 3. That's f of a plus h. Minus f of a. The meaning of that is everywhere there is a t, we will replace it with an a. So we'll have 2a plus 1 over a plus 3. And then that's all over h. Well, this is really 2a plus 2h plus 1 when you distribute the 2. And things are pretty similar as last time. We're going to get a common denominator. We got to multiply top and bottom here by a plus h plus 3. And top and bottom here by a plus 3. So it's going to be messy. So if we take 2a here and distribute it through, we'll get 2a squared plus 6a. Take the 2h and distribute it through, you get 2ah plus 6h. Take the 1 and distribute it through, you'll get a plus 3. Minus, start a parenthesis, okay, because we're going to have a whole bunch of stuff in there. We'll distribute the 2a to get 2a squared plus 2ah plus 6a. Distribute the 1 to get a plus h plus 3. This is all over our common denominator. A plus h plus 3 times a plus 3, and that was all over h. So that we don't have to write it as much, I'm going to distribute the negative in this step. So we'll change that to a plus. That's minus, 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 minus. Remember from Unit 1, anything that doesn't have an h should add to 0. 2a squared minus 2a squared, that's gone. We have a 6a, a minus 6a, that's gone. We have an a, we have a minus a, that's gone. We have a 3, we have a minus 3, that's gone. So what do we have left? We have, we also have 2ah and minus 2ah, that's gone. So we have left the 6h and the minus h, so that's going to give us 5h over a plus h plus 3, a plus 3. And now we're going to write it horizontally, divided by h. We'll give you a minute to get caught up. So that h is over 1. So this is limit as h approaches 0. 5h over a plus h plus 3 times a plus 3, now times 1 over h. Well, we have an h in the denominator, h in the numerator. Those divide out to 1. That becomes limit as h approaches 0 of 5 over a plus h plus 3 times a plus 3. And now we're ready for direct substitution. This is saying everywhere there's an h, fill in a 0. So this becomes 5 over a plus 0 plus 3 times a plus 3. So you could write it either as 5 over a plus 3 times a plus 3, or that's the same as 5 over a plus 3 squared. Notice our answer is identical to what we got before. And again, the meaning of this is our f prime of a. This is a function that subbing in any value of a will tell you exactly what the slope is at that value of x on the graph. So if we subbed in a is 6, that would tell us exactly what our slope will be in our original function when x is 6. So two different ways. You need to be comfortable picking one way and doing that way. Okay, but we're going on over both just so you have options for both ways. All right, so we're going to do one more both ways. So we'll do a polynomial this time. So we're going to do our x approaches a way. So that again is limit as x approaches a of f of x minus f of a over x minus a. So we will start out with limit as x approaches a. F of x, that's what we already have. So 3 minus 2x plus 4x squared. Minus, start a parenthesis. F of a, the meaning is everywhere there is an a, or everywhere there's an x, replace it with an a. So we'll have 3 minus 2a plus 4a squared all over the x minus a. We're going to distribute our negative. So that'll be 3 minus 2x plus 4x squared minus 3 plus 2a minus 4a squared all over x minus a. Notice the 3's add to 0. And when we rewrite it, we want to group things strategically as the same power. So I'm going to write 4x squared minus 4a squared minus 2x plus 2a all over x minus a. Because we need the x minus a to divide out. Well, in the first thing, we can pull out a 4. And by first thing, the first two terms, I mean. And that leaves us with x squared minus a squared. Well, we can pull out a negative 2 in the second one. And the reason we'll pull out a negative 2 is that'll leave us with an x minus a. So we got the x minus a in the second part, but we don't in the first part. Well, you might recognize that's the difference of two perfect squares. So we can rewrite the x squared minus a squared as x plus a, x minus a. To be able to divide out the x minus a, we would need an x minus a in every term. This is a term because it's a bunch of stuff multiplied together. That's a term. Well, notice we do have an x minus a in each of those. So the x minus a divides out of each of those because anything divided by itself is 1. And what we have remaining is 4 times x plus a minus 2. Anywhere there's an x, replace it with an a. That's our direct substitution, so we don't write a limit anymore. A plus a is 2a. 2a times 4 is 8a. So we have 8a minus 2. And that is what y prime would equal. The meaning of y prime is this is a function that could tell us the slope at any spot in our original function. So if we wanted to know at x equals 7 in the original graph, what's the slope there? We could now just put in 7 here and we would get 56 minus 2, so really it's a slope of 54. So the whole idea of the derivative equation is it allows you to find the slope at any possible point in the original graph, which is really huge. All right, one last thing we're going to look at. We're going to do the same problem, but we're going to do it the h approaches 0 way. So that's limit as h approaches 0 of f of a plus h minus f of a all over h. And you will have to memorize your definitions of the derivative. The definition of the derivative is those limit definitions. Okay, they will not be given to you like it was in Unit 1. So I have limit as h approaches 0. f of a plus h. The meaning of f of a plus h is everywhere there's an x, replace it with an a plus h. So I have 3 minus 2 times a plus h plus 4 times a plus h squared. Minus. Start a parenthesis. The meaning of f of a is everywhere there's an x, replace it with an a. So we have 3 minus 2a plus 4a squared. All over h. So we're going to do some neatening up. Let's multiply this out off to the side. A plus h times a plus h would give us a squared plus ah plus ah plus h squared. Or in other words, a squared plus 2ah plus h squared. But then keep in mind we're also going to distribute a 4 through there. So if we rewrite this, we'll have limit as h approaches 0. We'll have 3, but then we got to distribute the negative 2, so we get negative 2a minus 2h. We're going to distribute this 4 through to everything. So we'll have plus 4a squared plus 8ah plus 4h squared. And then we got to distribute our negative through to everything. So minus 3 plus 2a minus 4a squared, and this is all over h. When you're doing the h way, everything without an h should wipe out. It should add to 0 if you did it correctly. 3 and negative 3, they add to 0. Negative 2a, positive 2a, they add to 0. Plus 4a squared minus 4a squared, they add to 0. Now we have limit as h approaches 0 of negative 2h plus 8ah plus 4h squared all over h. We can divide out the h from everything, giving us negative 2 plus 8a plus 4h. And then we can do direct substitution. Everywhere there is an h, we can replace it with 0. So this gives us negative 2 plus 8a, which is our y prime. And notice it's exactly the same as what we got with the other method. So either method gets you to the same spot. Remember, this is a function that represents our slope at every possible point in y. So if we wanted to know the slope at x equals 2, you put in 2 for a, and we'd get back 14. So we know the slope when x equals 2 is 14. So if you don't have memorized yet, you want to start memorizing your a and h ways, your x approaches a and your h approaches 0 ways, because you will have to have them memorized eventually. Any time that is left in the period, you can either start watching tonight's video, or if you wanted to grab a book and start thinking about the problem set, you could do that as well. Have a great rest of your day.